Nice food.
Not really a soup, but thank you.
It's not a soup. It's a related thing. There we go. What we know. Last time I tried to give you a compliment.
Suits are more formal than I need. So you know you're still young. Once you get older, you'll be the same. You'll know the difference, and you'll be excited to get ties.
I can't.
That's the point of no return, by the way.
Yeah, I always say like sweatshirts for like Kleenex or anything. My girlfriend always corrects me on that. So I got a lot to learn. From here.
And then once you're happy about a tie, you know there's no return to your young days. Then you go, okay, it's time to retire. You found it?
It like popped up.
Best way would probably be just this after class. I'll show you. Happy Wednesday. Another jury day. That's starting to become a pattern now, right? Jury for class. It's whatever. Just wait till we get snow. No such thing anymore. COVID changed all that. Now we just meet virtually instead. So no more snow days. Monday, we ended by looking at Pascal's triangle, right? And we saw a nice convenient way to expand out the any binomial to a positive integer power. And that's how we were able to get x plus h cubed so quickly. We're looking for the difference quotient. Aren't you full screen, so why do you show up? Right. So again, typically, just so the algebra doesn't look too daunting, I do this in 3 steps. First step, we just did find f of x plus h. All right, then you go, okay, well, now I have f of x plus h. Take that, subtract out f of x. Because we haven't finished 8 yet. Through the power of technology and teachers' prerogative, I can just copy and paste. Then minus, I didn't even use the parentheses, but minus x cubed. Dating, and it is visible there, that's fine. Cubed minus x cubed. Left with 3x squared h plus 3x h squared plus h cubed. Final step is to take that and divide out an h. Numerator can factor out an h, right? H over h is 1. then there's your difference quotient. Again, it's implied that h cannot be 0.
Do we take the h off of the 3x squared h, or do we take it from the h cubed?
Everything.
Cool.
Everything, right? Because h is
Take an h from
yeah, because h is common, right? I'm factoring out an h from all 3 terms.
Okay.
And then when you take Calc 1, hopefully next semester, there's one additional step, right? Then you just pass that through the limit and you have your derivative. Difference quotient for 1 over x squared. First, g of x plus h. One over x plus h squared. You can expand that out. I'm just going to leave it for right now. So take that, subtract out a g of x. And simplify. So if you're adding fractions, what's the rule?
The same.
What is that called? Do you remember what that's called?
Common. There's something.
More specifically,
Least common factor.
least common denominator,
Oh.
which is the least common factor of the denominators. Well, the least common factor between these two, or least common multiple rather, between these two, it's just their product, right? What was it?
I was just gonna say like how to do it.
Yeah, it's just their product. In general, you can always do that, right? Because then at the end, when you simplify your fraction, you'll get the LCD. So if ever you're in doubt, just multiply all the denominators together and use that, and then simplify at the end. So our common is x squared times the quantity x plus h squared. For the numerator, the first term, what is missing from the common denominator?
The x squared.
So you multiply the first term by x squared over x squared. Right, you're multiplying by 1 so you don't change it, which means the numerator just becomes x squared. Remember that? Sign stays the same. And then you do the same thing for the next term. Right? What's missing from the common? The x plus h squared, right? So you have to multiply numerator and denominator by that. We can leave the denominator alone. Now we just have to simplify the numerator. And start by expanding out the x plus h squared. X squared minus x squared, that's 0. Left with negative 2xh minus h squared over x squared times x plus h quantity squared. And purely optional, purely for aesthetics. Factor a negative out.
Let's say we have a test and we leave our answer in the one before.
That's fine. Again, that's purely aesthetics. But of course, if this was on a test and you stopped here, you'd only get 2/3 credit because there's still one more step to do, right? Right here, right? Because there's still one more step we have to do. Divide everything by h. Remember, we're finding difference quotient. Sure is. 7 years in your position, I've earned that right.
One of those.
Of course, when I was a student, we didn't have this technology either, so I couldn't even use it as a student to take notes. Also wasn't allowed to use a calculator. I remember when I was in school, the computers were DOS. Wasn't that fancy Windows that you have now with the point and click. No, we had to type everything in. So this is known as a complex fraction. Remember that? Which we're not allowed to have. Right. Rule of thumb, and actually it's not just rule of thumb, it's the accepted rule with fractions. No complex fractions and no mixed numbers. So you keep your fraction improper. So what is the rule with dividing fractions? Multiply what by the reciprocal of what?
The whole thing. Wait, what was your question?
What's the rule when dividing by fractions?
And you just get the numerator, you leave it, and like you said, you multiply that by the reciprocal of the denominator.
Numerator times reciprocal of the denominator. And by the way, that is actually the definition of division. In mathematics, arithmetic, you were told there are 4 operations. You were lied to. There's 2 operations, addition and multiplication, that's it. Subtraction is not an operation. Division is not an operation.
The subtracting is just adding the next one.
You add by the additive inverse. And division is you multiply by the multiplicative inverse. That's the formal definitions. Not too late now. I actually could have just pasted again. You know what I'm also going to do? Same time with the numerator, I'm going to factor a common h out. Because I'm lazy and don't want to have to write it again. You get h over h. Thus, our difference quotient would be 2x plus h all over x squared times the quantity of x plus h squared. And there's your difference quotient. Again, calculus, you just pass that through the limit as h goes to 0, and you have your derivative. Are there any questions on that? All right, a first look at functions. Yes. For pre-calculus.
Is that the first question? Like, is that like the very first thing we just did? Or that, the G1, the F1, that's good.
Monday.
This here, we can
Yeah.
do this Monday.
The question.
So again, see me after class, and I can show you. And so yeah, we did like 6 or 7 problems on Monday. So I'll show you. There it is recorded. So you have access to them. I'll show you how to get to it. But remember that a function is a mapping from one set into another set. Typically, for the calculus sequence, since calculus is the study of the set of real numbers, it'll always be the set of reals into the set of reals, or a subset of the reals into a subset of the reals. And so it typically looks something like this. Right, F is a mapping from the reals into the reals. This first set is the domain. Second set's the codomain. That's an F, yeah. The domain is the set of all values that the function can take. Right, so it's a set of all values you can plug into the function. The codomain is just the set that the results belong into. It does not have to be what's known as the range, right? The range is the set of all values that the function gives you. Range and codomain do not have to be the same, but the range will always be a subset of the codomain. It's part of. Right, so the official definition of subset is A is a subset of B if and only if every element of A is also an element of B. Right, but the reverse is not true, right? Just because it's in B doesn't mean it has to be in A. So if we just looked at 1 to infinity, that'd be a subset of the real numbers. Right? They're all real numbers, right? But it's not every single real number because it's nothing less than 1. If the range and the codomain are equal, then the function is said to be onto.
I'm sorry, I don't really understand this, what the codomain is.
It's just a set that the outputs belong to. Right, so if you plug in a number and you get a real number, the codomain would be real numbers.
The output's not the range in that case.
The set of all outputs is the range. Right, so the easiest way to look at it is if I do this. Look at x squared. Right. Domain and codomain are all real numbers, right? Because you plug in a real number and you square it, you get a real number. But the range is not all real numbers.
Positive or greater than or equal to 0.
Right? It's all non-negative real numbers. So the range would be non-negative real numbers. If I wrote it this way, which is non-negative real numbers. All the positive real numbers plus 0. Now that function is on to.
I learned domain, but what's the difference between domain?
Codomain is output. So domain is input, codomain is possible output values. Range is output.
Is the range is the subset of the codomain, which
Right.
is all the values that represent
What you can get, yes.
so y on the graph.
Yes. It's the y-axis, yes. Domain is the x-axis. Domain is the input. Codomain is the entire y-axis. And then range is just the actual values you can get. It's a little weird.
You said that if codomain and range are equal,
Then the function is onto.
Onto what?
Oh, that's what it means. It's the function is just called onto.
Single word.
Yeah.
ONTO.
Yeah.
What does it mean?
And onto.
What does
This means that the entire codomain is covered. Right? So the function spits out every value in the codomain. So that just means positive real numbers. And then that's unioned with 0 because 0 is not positive, nor is it negative. So the domain is the set of values that you can plug into the function, right? So it's the values that the function will accept. The codomain is all the possible values you could spit out. Right. But the range is the actual values, right? So just because I have a codomain of all real numbers doesn't mean I can get every real number from the function. The domain is set that is the values you can put into the function. The good news is you really don't need to worry too much about codomain. That's more theoretical if you take a functional analysis course. But there is a difference between codomain and range. Most of the time when you're given a function, the domain is implied. Right, so very rarely will I give you a function like, for instance, f of x equals x squared and actually tell you what the domain is. Right, it's an implied domain. So how would you determine what the actual domain is? Well, there are several rules you have to remember. We're going to talk about 2 right now, and then as we study future functions, so like when we study logarithmic functions, I'll give you the rule for that. Exponential, I'll give you the rule for that. Trig, I'll give you the rule for that. So the 2 big ones. You can't divide by 0. And if you have an even indexed radical, right, so square root, 4th root, 6th root, what's under the radical cannot be negative. So you can't take an even indexed radical of a negative, right? So square root of a negative you can't do, 4th root of a negative, 6th root, so on and so forth. Now, actually technically you can, but that then puts you into the complex numbers, right? And calculus is focused on reals, so we just say you can't take the square root or the fourth root of a negative. So when you're trying to determine domain, that's what you want to do. You want to look at, okay, what can't we have? So what values are going to have to be removed from the real numbers? Well, look at 3x minus x cubed. Do we have a denominator? So we don't have to worry about dividing by 0. Do we have a radical? No. So the domain's just everything. Right, so this represents, it's a blackboard bold R. That means the set of real numbers can also be represented in interval notation, negative infinity to infinity.
You determine this using the two rules.
Yeah.
Can't divide by 0.
Right.
And was it the inverse reciprocal of the function? Is that what you said?
No, radical.
Right.
Not inverse, just radical. So you're looking at even indexed radicals. Don't worry, I have examples of those. So we'll say them. All right, so these are the three ways to represent the set of real numbers, right? You can just use the blackboard bold R. This here is known as interval notation. This is called set builder notation. Unless the problem specifies, it doesn't matter how you represent the set. Right? You can use either interval or set builder. All right, and this is red. The set of all x such that negative infinity is less than x less than infinity. Right.
Just to the right of the domain and like whatever's highlighted, can you break that down from a fundamental standpoint?
What do you mean fundamental standpoint?
Like, that's like the absolute value, right?
No. The braces represents it's a set. This is just a vertical bar, a vertical line, which means such that. So that is red, the set of all x such that negative infinity is less than x is less than infinity. Right, so this tells you the variable of the set, which is x, and that's the rule of the set.
Such that.
That represents such that. There's actually several shorthand notations for such that.
Sides,
Yes. Welcome to the language of mathematics.
I'm writing more now than Comp 2.
Believe it or not, math is a writing course. There was a 500-page proof.
You have to write an essay? Oh, no, you said.
In upper level,
There's proof.
yeah, upper levels, essentially, it's just proofs, which you could think of as essay writing. It's not really an essay in the sense of what you're thinking of, like in a comp essay, but it is paragraph form.
You have to explain like how.
Yes.
You,
Logical
letter,
steps.
yeah.
Yep.
You have to like do your work on the side of how you wrote everything.
Depends. For publishing, you don't. Right, and then you just look at the person and go, well, if you don't see that, you're too stupid to talk to me, and then they just cry and accept your proof. Well, proof by intimidation. Domain of 5 over x squared minus 9, right? So again, 2 rules. So you ask yourself, do we have a denominator? What's the denominator? So first go, okay, we know that x squared minus 9 cannot be 0. So solve it. Right, that would mean that x squared cannot be 9. Right, so the absolute value of x can't be 3. Which of course means we have x cannot be negative 3 and x cannot be positive 3. Well, if you really want to be fancy, x cannot be in the set of negative 3 and positive 3.
How do you draw that symbol? Realize slow motion.
Oh, an E for element with a slash to it?
Yeah, and then slash just means not. Right, so that would mean element of or is in.
Element cannot.
Right, so again, in English, that would be read x is not in the set negative 3, positive 3. Meaning you can't have x being equal to negative 3 or positive 3. Now you ask yourself, do we have a radical? No. So since we know x is not negative 3 and x is not positive 3, we remove those 2 elements from the real numbers. Again, there are 2 ways to represent it. Interval notation. Negative infinity to negative 3, unioned with negative 3 to positive 3, unioned with 3 to infinity, right? So it's everything but plus minus 3. Right. Set builder, set of all x such that absolute value of x is not equal to 3. They mean the same thing. Interval notation is most common. Right, you'll see that probably the most. But I mean, if you're removing like 8 elements, step builder is probably easier to write. Do we have a denominator? What's the denominator?
Sorry, I have a quick question about
Yes.
the last one. But it would not be acceptable to say the main is the fancy R for real numbers not equal to plus or minus 3.
Right, that would not be acceptable. That doesn't make any sense. Right, because
All real numbers not equal to.
right, because what you're doing is you're writing this, right?
Yeah.
That does not make sense. You're saying a set is not equal to 2 elements,
Okay.
which mathematically that would make no sense.
All right. Okay.
Right, so you might see something like mathematically that is not how you would represent it.
Okay. All right.
Right.
I'll avoid that.
Right, so when you're doing domain, it's always going to be one of these 2 forms, either interval or set builder. What was our denominator here? Which means that cannot be 0. So now solve. Right? Because it's a denominator. Right, you're not allowed to divide by 0. The universe blows up.
Zero.
We're not.
Oh, yeah.
Right. We're saying you're not allowed to. So what we have to do is we have to say, okay, so when does the denominator equal 0? And we have to take those elements out. Well, the first one doesn't have a denominator, so you don't have to worry about that. The second one does, right? So we said x squared minus 9 cannot be 0. That's where we found out that -3 and +3 have to be removed. Right, so we're doing the same thing. It's just it's a different denominator now, right? Think back to when you took algebra. How would you solve this?
Back on X, left with the quadratic.
Can you? Is that always true?
Not always, then you can use quadratic formula.
Right. So quadratic formula would always work, right? Or you can try and factor it. Can this one be factored? What does it factor to?
X plus 6 and X minus 4.
Why do we do this?
Find the prohibited values for the denominator.
Just in general, if it equals 0, so ignore the fact I'm trying to do a denominator, right? You're solving this. Why are you factoring it? What's the reason? Right, but why?
I don't know what the rule is called because multiplication by 0 is always 0.
Called the 0 property.
Okay.
The 0 property states if you take the product of real numbers and you get 0, then at least one of those numbers is 0. A corollary to that would be if you take the product of real numbers and it's not 0, then none of the numbers can be 0. Right. So that means that none of these 3 factors can be 0. That means x cannot be what? -6, 0, nor 4.
Second one, the one in the middle.
This one?
Yeah. It says x minus or x -4 cannot equal
Oh,
0.
supposed to be a 0 in there.
So is that second line, that's the full set builder notation style?
No, that is just saying what this means, right? So
Yeah.
that's interpreting this. This is just saying what x cannot equal. I haven't done the actual domain yet. Are there any radicals? There is. Yeah. What about plugging in 0?
I kind of forget what radical means. Like 0.
It's a root, right? So root 2, radical 2. Fourth root of 2 is a 4th degree radical.
When you say 4 root, it's like square root?
4th root,
Root?
What?
right? So 4th root of 16 is 2, because 2 to the 4 is 16.
The one that's highlighted.
Yes. Well, x can't be 0, right? From the first step. Second one says x minus 4 can't be 0. Well, what minus 4 is 0? 4, right? So x can't be 4 either. And the same thing for x plus 6. X plus 6 can't be 0. So what plus 6 is 0? -6, right? So there are no radicals. So we don't have to worry about that. In interval notation, this would be our domain, right? Negative infinity to -6, right? Because we have to remove -6 out from the real numbers. Then -6 to 0, 0 to 4, and then finally 4 to infinity.
I just have a question. So it says like -6 to 0.
Yes.
But then never mind. That's not in. I was just
Right. It's open, so they're not being included.
The set builder for this? Can we write x such that x and then cannot equal?
Yeah. Right. So you can do this.
It's all real numbers. Like, you could just write x such that x equals and then the r symbol, right?
So be careful with that. There'd be no point for that. That'd be redundant. Right. But you don't want to write this because that doesn't make sense unless x is a set. Right. What you would write instead is x is in the real numbers. Right. Or if you're doing domain, you don't even have to write x is, you just write out the r. Right.
Really good. I was there for like a year, bro.
Ever after you can show up at school every day.
I gotta say this.
Right now. I'm gonna say it later.
Right. Do we have a denominator?
Differently than the
Which would be what?
on over on.
But you're not wrong. There technically is a denominator.
On the,
Technically, the denominator is 1. But 1 is never 0, right? So we can just ignore it. So we can ignore that. Right? It was just like the first problem. Right, where technically we had a denominator of 1, but since 1 is never going to be 0, we don't have to worry about it. Do we have a radical? What is the index of the radical?
Even.
It's 2. Square root is index 2, right? That means that what we're taking the radical of cannot be negative. Which is represented as x minus 5 greater than or equal to 0. If you solve, that means x has to be greater than or equal to 5. So the domain (5 to infinity) closed at 5.
Well, what does the first bracket mean?
Closed.
It's like,
Either it's only from 5 to nothing.
The point is included if it's closed. Right, so up here, -6 is not included. Right, because that's an open. This is closed, so the 0.5 would be included.
Like on the graph would be a closing circle.
Yes.
And it goes.
If you look at the number line, yeah, it's a
Oh,
closed circle
there.
at 5.
Do we ever have to graph after we found out this?
Maybe in the homework, but not. I don't usually do number lines.
Oh, let me see.
You might have said this, but it can't be less than 0 because of the radical, right? Okay.
Specifically because it's an even indexed radical.
Now, for set builder, would it just be bracket X such that X is greater than or equal to 5? You don't have to specify real numbers there?
No, it's implied.
Why it's, oh, okay.
For us, it's implied. If you're just dealing with like a set theory class, right? You're in a class of set theory, then yes, you have to specify what set we're dealing with. Do we have a denominator? No. Do we have a radical? Is it an even index? That means what's under the radical has to be non-negative.
So there's a radical because there's a square root,
The square root is the radical, yes.
and then we can't have a negative number under the square root
Correct.
of under the radical.
Under any even index radical.
I did this in like a last class where it said if you had like a negative number under a square root, it became the imaginary number like I.
Becomes complex. We're dealing with real numbers right now.
Yeah.
Yes. Calculus is the study of the real number set.
So when would I come into play again? Like
When
what?
we study polynomials, we will consider the complex numbers when we're solving for zero, but then not again until senior level math. Complex analysis is the study of the complex number system. It's essentially calculus, but on complex. Unless you're a physics major. Then you deal with it a lot in quantum mechanics. Solving an inequality, right? If you have like a quadratic or any kind of function, really, you first want to determine the breakpoints. Breakpoints would be whenever the denominator is 0, which of course we have none here, and when the function is equal to 0. So just pretend we're solving x squared minus 8x plus 12 equals 0, right? How would you do that? Try and factor if possible. Can this be factored? What does it factor to?
Those two, excellent.
Thanks, guys.
Breakpoints. X equals 2 and x equals 6. Those are our two breakpoints. So there's only one way for a number to go from positive to negative, and that's to pass through 0, right? That's why they're breakpoints. So it's where the function is equaling 0, so we know that those are the only points where we can possibly switch from positive to negative. Keep in mind, just because it equals 0 doesn't mean that it switches, right? It can just touch 0 and then go back down, right? So it can be negative and negative. So now what we have to do is set up test intervals. The test intervals is just the set of all real numbers, and it breaks at the breakpoints, right? First breakpoint is 2. Then it goes to 6. Right, and then that's it. What you want to do now is test the sign of the polynomial within each interval. And again, remember, up to 2, it's either going to be strictly positive or strictly negative, right? Because the only way for it to switch sign is to actually pass through 0. So you pick any value from negative infinity to 2. 0 is in there. I'm going to use 0. I'm going to use the factored form too. We do not care what the value is at 0. We just care if it's positive or negative. At 0, it's negative and negative. Negative times negative is positive. Now we pick any value between 2 and 6. Oh, 4. This will be positive. This will be negative. Positive times negative is negative. And then pick any value greater than 6, 10, You'll get positive times positive, which is positive. Now look at your inequality. What's the inequality? Greater than or equal to? Those are the two intervals. Since it's greater than or equal to, the breakpoints are included. Call that solution set S. So the solution set to this inequality is negative infinity to 2 unioned with 6 to infinity, closed at 2 and 6.
Not the bad solution set.
Not yet. This actually is going to be our domain as well, right? Because we don't have a denominator to worry about. But that's just the solution set of this inequality.
Because there's a denominator.
We'd have to then take out any points where that was 0. And that just also happens to be our domain.
Those three dots mean again.
That means therefore. There's actually an entire class dedicated to learning the language of mathematics.
Write a D, how you write a D? I wish I knew.
Don't worry about it.
That's all I've been trying to put this on.
You don't have to worry about it.
So.
You can just use a regular D if you want to. I only use that D because it's representing domain. So domain is typically a script D. No, F is just because I write in cursive.
You got that in interval notation?
That's interval notation, yes. Right, set builder would be or this means or.
B means or.
Not really a V, it's an upside down caret. Right, caret would be this, which on calculators means raised to a power. In math, that means and. That's from logic.
I thought the U was like and,
Union.
like union.
No, union is or. Right, because union is one set or the other set, right? That's an or. Intersection is both, right? So it's in A and in B. And someone said, why don't you just write or? When you're writing a 300-page proof and or appears 100 times, it's easier to just use that symbol than to write out 2 letters all the time. We're lazy by nature.
I say you have to write this 300-page proof. I don't know if that's
Your
being
hand.
lazy.
Like,
We used to.
but how do you write that on?
If you're familiar with LaTeX, you have, well, if you're ever doing anything math, if you're writing a math paper, you're typically writing it in LaTeX anyway.
It's like,
It's a coding language. Your textbook is written in LaTeX. Any math textbook is LaTeX. Any math paper you read is LaTeX.
You have to write all this down in.
Yes.
happy, it's cool. How many pages?
Oh, it's awful. Because you also have to make sure that your document begins with the command begin document. And then if you're actually doing text, then you have to somehow signify that this is actual text and not math text. That's just awful. So you look at the code and then you look at the output and you just go, please don't look anything like, how the hell did you get this from the code? I leave that for people smarter than me. This was supposed to actually be f of x equals. Don't know what happened to it. There we go. Now it's there. F of x equals this. Do we have a denominator? Yes. What's the denominator? Be careful. That is technically not the denominator. It's the cube root of x cubed minus 8, which for our purposes actually doesn't matter. Right? Because if cube root can't equal 0, that means what's under it can't be 0. Right, so I'm just going to go with x cubed minus 8 cannot be 0, which means x cubed cannot be 8. So x cannot equal what?
Absolute value of two, well, plus minus 2.
What's negative 2 cubed?
Oh, negative 8.
Just positive 2. Now, again, that's because we're dealing with the real numbers. There's actually 2 other zeros, but they're complex. Do we have a radical? What is the index? What was it?
Odd.
Is that even or odd? You're allowed to have negative numbers under an odd radical. So the only restriction is x cannot be 2. So there's your domain.
Two, not the bracket.
Because x cannot be 2. Right? Otherwise, the denominator would be 0 and then the universe blows up.
But on the
Right, you're looking at the previous 2, right? They weren't denominators. Right, so we didn't have to worry about setting something equal to 0. This one has a denominator, right? X cubed minus 8. So we can't let that be 0. So when is x cubed minus 8 0? When x is 2. So we take 2 out of the domain. Does that make sense?
So you said something about a number under the radical can't be negative, right?
No, depends on the index of the radical. If it's an even indexed radical.
How can you tell that if this is positive or negative under the,
What do you mean positive or negative?
like when you ask for the radical, how can you tell that it's positive or negative? Like, cause he just had an answer, he just knew it was like negative. And that,
Well, the radical itself isn't positive or negative. I think you mean the index of the radical.
yeah, the index.
So you look at the index of the radical, whether it's even or odd. Well, this is a cube root, right? So what's the index? Which is odd. Right, square root, we don't write the 2 because it's implied. But technically, be written that way. Right, so that is the index, right? So you just look at what's above like this little caret here, right? That's a 3, so it's cube root. If that was a 4, it'd be the 4th root. In which case, then the index would be even, right? Then you know, okay, it's even. We can't have a negative under the radical. If it's odd, you can.
Oh, okay.
Right, because if you raise a negative number to an odd power, it's negative. Right?
Mhm.
But if you raise a negative number to an even power, it's always positive. That's domain. Now, keep in mind that we were just dealing with functions, right? It wasn't like a word problem. If I gave you, so if I said, okay, this is a function, but it's now with respect to time, that would not be your domain. Because time can't be negative. Time starts at 0. So not only do you have to worry about finding out, okay, what the function can equal, you also have to understand physical interpretations. Right? If you're dealing with a cost function, you can't produce negative units, right? So your domain can't include any negative numbers. And theoretically, you don't want it to be 0 either, right? Because producing 0 units, well, that just, why even be in business then, right? If you're not going to make anything. There you are. Let's now look at range. All right, so remember, range is what the function gives you. This problem is extremely tough. I don't know how we're going to get through it. What's the range of this function? Be careful, it's not technically 4. Range is a set. So it's the set 4. But yes, there's just one element in the range, right? It's always going to give you 4 no matter what you plug in. So it's just the set of 4. That's it. Keep in mind, again, if you wrote that, that technically does not make sense. You're saying a set equals a single element, which is nonsense. I'm trying to think of a good analogy in English.
But why does that not make sense though? Because if the set is just 4.
Because 4 is a single element. A set cannot be an element. Set is a set.
I think I understand. I'm just saying like it still is just 4, correct? Like it's the
set of 4. So it has to be.
Sorry.
Putting a little R there makes a difference.
Has to be this because range is a set.
No, like I get why, like to be correct, you have to write it like that. I just like.
But that's why, right? If I was looking for just like a single value, then you could write this, right? But because you're looking for range, you have to write it as a set because that's what range is. Right? Again, I can't really think of a good analogy like in English, but just think of a nonsense sentence. That'd be the analogy. But like purple elephant weed. It makes no freaking sense whatsoever, right?
That's essentially
That's essentially what That's essentially what that says, right? It's nonsense. It's a nonsense statement. We did used to call our tutoring room the meth lab, so. Range of 4x plus 3 over 5. To determine the range, right? So again, remember, range is everything that the function can give you. Pick an arbitrary value. We're just going to call it k. Yep. Yeah, h is fine. But we're just saying it's just some arbitrary value. Set it equal to the function. Now solve for x. I don't know. I'm not familiar with that terminology. You also have to remember it's been, a few decades since I've been in school. I was in school long before Common Core. So they may teach differently now. In fact, I know they do. Which of course means I'm really looking forward to my first parent-teacher conference. When the math teacher tries to explain why it has to be done this way, and I just go, I'm sorry, what's your degree in? That's right, I have a doctorate in math. I'll have a doctorate by then. Don't tell me how to do math.
That's a weird flex.
Believe it or not, teachers try to flex. They try to flex. Well, I'm an educator. So am I, and I have a doctorate. What's your point? I probably would not be allowed back in the school. My wife would not let me get a Lamborghini. I tried getting sports car, and she goes, how are the kids going to fit in it? That's not my problem. Never said I was taking the kids with me.
Now they have like the trunk station.
Yeah.
Honestly, my son would probably love it.
So you crash.
No, he'd love it when I crashed.
You said it in the front?
No, he watches videos whenever something crashes, he giggles. He loves crashes. Too. He also giggles when he crashes into things, so
Yeah,
run to a table and he laughs. Okay, there we go.
he doesn't cry.
Sometimes he does. Usually he just giggles.
You be teaching them that.
Not yet. Not yet.
You gotta get it.
I say by the time he turns 18, he'll have a PhD in math or physics.
Let him young.
If he chooses a field other than STEM, I don't have a son. I'll train him early. So you know what he's going to be.
Speaking like medical terms,
Mhm.
and knew where all the bones in his body were.
Go for the parents. Right now, I'm just trying to get him to calm down. He's got unlimited energy. I'll deal with teaching him later. It doesn't work. I've tried alcohol. It doesn't work. I think he just likes it now.
It's starting to.
Sadly, starting my bad habit early. Go to grad school, you develop a habit for alcohol. How you get through it?
And coffee.
True Irish coffee.
Uh,
Cup of whiskey and a shot of espresso. That's a true Irish coffee.
That's in the cup.
My wife would kill me, but you'll never know. No one needs to know. So ultimately, x is going to be 5k minus 3 over 4. The range is the domain of 5k minus 3 over 4. Right. So what you basically do is you just look at it and you go, are there any values that you cannot plug in for k? No, right? So k can be anything. But since we're saying k is an element in the range, that means the range is everything.
For linear functions like that, can we just see that the slope is 4 over 5x? That's like the y so it's 0 over 5. Then just know that's.
I mean, you can just look at that and know the range is all real numbers.
Yeah.
This is mathematically how you determine it. So on a test, yeah, I don't care, but be careful. Because if you write it down wrong, you don't show work, you get no credit. I'm not as concerned with the right answer as I am with the process you used to get there. Math isn't about plug and chug. Math is about understanding the process. And that's how I grade. It's a little bit tougher here because I typically don't let algebra be worth that much. But I mean, that's kind of the whole point of this class. So arithmetic usually doesn't. So if you have like 5 minus 3 equals 4, you'll probably lose like a point for an arithmetic error if everything else is right.
So what does that represent? The R?
That means range is all real numbers.
Range over. So we need to be the.
Yep.
Oh.
So what that means is this function can spit out every single real number. What about 4x minus x squared? And we start the same way. And we want to solve for x. So just move everything to one side. So we get x squared minus 4x plus k is equal to 0. Well, that's a quadratic. Quadratic formula. What is the quadratic formula?
Equals negative b plus or minus square root b squared minus 4ac all over 2i.
Now, do that for this problem.
Negative 4 plus or minus square root 4 squared, which is 16, minus 4k all over 2.
That's the quadratic formula.
Mhm. I'm just going further to make it easier to see. Under the radical, you have a 4 common, right? So you factor out the 4, you'll be left with 4 minus k. But square root of 4 is 2. Four minus k is under a square root. That means 4 minus k has to be non-negative. That means 4 is going to be greater than or equal to k. Which is the same thing as k being less than or equal to 4.
So you isolate the radical.
Well, I'm not really isolating the radical. I'm just looking at what are the values of k. Right, so what values can k be? Well, 4 minus k has to be non-negative, right? That gives me my restriction on k. Right, so that's so again, think of it like, okay, here's your function. Find its domain. Well, again, we said k was just some arbitrary element in the range. So if k has to be less than or equal to 4, then your range is every real number less than or equal to 4. Which is negative infinity to 4.
How did we determine that it could be 4 as well?
What's the rule for under a square root? Right, what you're taking the square root of has to be greater than or equal to 0. So right here. So because it is greater than or equal to, that's why 4 can be included.
Yeah.
Piecewise functions. Right? Just as the name says, it's a function that's in pieces. So what this says is if you plug in any value greater than or equal to 0, the function spits out 4. Plug in any value that's less than 0, the function will spit out negative 4. Which means this range is easy. What's the range of the function? All right, so what are the possible outputs?
Negative 4 and 4.
Yep, that's it. That's your range.
So if you plug in like 16
It's going to be 4.
for X,
Yep, f of 16 is 4.
the f of X, which is your Y value, would still be 4 as well.
Yeah, because that's, yeah, f of 16.
So this piecewise function is really just two points, or is it two?
No, it's 2 lines.
Is two vertical lines, or
Yes. No, horizontal.
couldn't the range technically be negative infinity to negative 4?
Now you're thinking of domain. Horizontal.
So we're talking about the
Right, the range is the y-axis. Right, so the horizontal line means every value of x equals that value, right? So every non-negative value of x gives you 4. If it was a vertical line, yes, that would mean that y goes from minus infinity to positive infinity. So what about this one? And we'll just look at each piece. I'm going to use fx, I'm going to use k. For x greater than or equal to 2, we get 4, right? So k would be 4. All right, so there we go. We're done. Because that's how the first piece is defined. If x is between -1 and 2, k would have to be negative x, right? The output is negative x. X would then be negative k. Right?
How would the x be negative?
Because it's negative x, right? So you're solving for x.
Okay.
Now remember, just because it's negative k doesn't necessarily mean it's negative. Negative times negative is positive. Right? So all it says is whatever value k is, you're multiplying by -1. So now go back to your inequality and replace x with negative k. What happens if you multiply an inequality through by a negative? The inequality flips, right? So this would mean 1 is larger than k, which is larger than -2. Which, of course, is the same thing as saying -2 less than k less than 1, right? So that second piece gives you all values between -2 and 1 exclusive, right? Meaning -2 and 1 are not included. When x is less than or equal to -1, the function spits out x plus 2, right? So k would be x plus 2. That means x is k minus 2. Now you do the same thing. Replace x with k minus 2 in your inequality. That means k is less than or equal to 1. I added 2 to both sides, right? Because I'm solving for k.
Get rid of it.
Because I'm trying to
Oh.
find values for k,
I see.
Right.
There's -1, now it's positive.
right? The range of the function is the union of all the ranges. So I'm going to write it this way. Set 4 unioned with the interval -2 to 1 unioned with -infinity to 1.
That'd be bracket.
That one is a bracket, yes, because it's less than or equal to, right? But isn't that middle interval contained in -infinity to 1?
So it's us.
So there's your range.
So how do you get rid of the number?
-2 to 1, right?
Yes.
Isn't that actually in this interval here?
Yeah.
So it kind of just gets absorbed.
Does the set parentheses mean that -2 and 1 can't be point?
Right, but 1 is included here. Right, it's just saying that you don't get -2 or 1 from here. Right, I'm not doing intersection, I'm doing union. -2 is included in this interval, right? So it'd be in their union.
Really, that middle row is just like.
Yeah.
unnecessary.
It's redundant, right? It's contained within that interval. So the union of those two would just be -infinity to 1.
If we left it on the first one where the -2 and 1 were still in, like as our answer would be.
You'd lose some points for not simplifying.
Comment like 1.
Couple.
A couple sometimes mean 2.
Yeah.
Well, the foot of the problems is where.
So we're at.
The way we're going to on our phones.
Don't say that.
Sounds good.
Oh, is that ours? That's all you. Yeah, I'm in there too, bro.
Open the clothes.
We can start a group chat on Teams.
Yeah, for real.
Laughing.
Everyone pass. What?
You better learn how to do domain and range because it's one of the most important things.
Oh, that's a 1.2. I know, right?
You'll be doing it a lot in calculus. Again, it's an implied domain. Questions on domain and range?
You're office hours?
Hmm?
Office hours.
I don't have office hours.
Don't work for you.
Yeah.
Technically 40 minutes after this class.
You got
Plus you can then schedule virtual
you got
appointments.
this video too also, right?
Yep.
I like 40 minutes after this class next week. Sound good?
Well, no, it's just, you can stay.
Save that. Is that it?